So just to provide some help on some of these charts here, obviously remember when we're finding x-intercepts, the top, we're setting the top, we're trying to see what would make the top 0, which for this one here would just be that x is equal to 0. And my y-intercept is when I set x equal to 0, which again would make my top part, or the y-intercept, we're setting x equal to 0, which would then say that y is 0. When we're looking at things, vertical asymptotes, horizontal asymptotes, well, my vertical ones come from my denominator again, so it's -7, and it's 1. And my horizontal one, because the denominator would expand to a quadratic, and the numerator is a linear, it's going to be 0. Now, OA would be an oblique asymptote, which happens when the denominator is lower than the numerator, and I'm going to show you that below. And holes would happen if things cancel out. So this time there's none, and this time there's none. So when we're factoring this one out here, a quick factor of this would be that this is x minus 5 and x plus 2. And the bottom here I could factor out a 2, and then it would work out to, because when you factor out a 2 out of this one here, you're left with x squared minus 4x minus 5, which means x minus 5, x plus 1. So these cancel out. When we're finding, when these cancel out, you're left with just this rational, which when we're doing our x-intercepts, well, because that cancels out, it's no longer an x-intercept. And my only x-intercept is going to be when x plus 2 equals 0, so that's when x is -2. And my y-intercept, I'm going to set x equal to 0, so then my y-intercept, I'm going to set my x is equal to 0 in this. So we have 0 plus 2, all divided by 2, 0 plus 1, which is going to be 2 over 2, which is going to mean that my y-intercept is 1. When I'm dealing with my vertical asymptote and my horizontal asymptote, well, here I divide my leading coefficients, which is 1 and 2, so that's going to be 1 over 2, and my vertical asymptote is just going to be at x equal to -1. There's no oblique asymptote, but this time I'm going to have a hole, and it's going to be at x is equal to 5. Now, to find out exactly where that hole is, you're going to plug in 5 for x. So you have 5 plus 2 over 2 times 5 plus 1, which gives me 7 over 2 times 6, which is 7 over 12. So really, really small number. So my hole is at x equal to 5, and y is equal to 7/12. And the last thing, when we have this type of scenario where the numerator is bigger than the denominator, we have to do our long division to figure out where the oblique asymptote is. So this would have an oblique asymptote, and what we would do is x squared plus 0x plus 2, putting in our placeholders. And when we divide it here, we have x cubed minus 5x squared plus 3x plus 10. Well, this is with an x here to make that work out, so plus 0x squared plus 2x. When we subtract that, we get -5x squared plus x plus 10 when we bring this down. And then what we're left with here is we want to multiply this by -5, so we have -5x squared plus 0x minus 10. And then when we subtract these away from each other to get rid of that, we get x plus 20. And all we care about is this part right here, and that is where my oblique asymptote is this linear line, like y is equal to x minus 5.